Kojo's Math, and we're going to get started right now. So we're going to start with the Pythagorean Theorem. So let me get this on here. Oops. Okay, so today we're talking about the Pythagorean Theorem, and it's used with right triangles only. You can only use the Pythagorean Theorem with right triangles, anytime you can form a right triangle. Now there's some parts of it that you need to know. The first part is that the legs are the two sides of the triangle that make up the right angle. So they're going to intersect so that they make up the right angle. So the two legs you can always identify by looking for the right angle in the triangle, and identify the two legs by looking at what makes up the right angle. The hypotenuse, and yes, you need to be able to spell all of these terms. The hypotenuse, Hypotenuse, is the side that is always directly across from the right angle. So here's the right angle. It's the one that's always directly across from the right angle. The legs are labeled A and B, and the hypotenuse is always C. And A and B are interchangeable. This could be A, this could be A and B, and so forth. So you could have A and B, or you could have A and B. It doesn't matter. So they're interchangeable. So what does that lead us? Well, there's a theorem that you use to find the measurements. It says that the Pythagorean theorem says that the addition of the square of the legs will give you the hypotenuse squared, which is, what is the hypotenuse? You think of a graph. What is the hypotenuse really? It's the shortest distance between 2 points. It's a straight line. So if we have this point on the graph and this point on the graph, the hypotenuse is the shortest distance between the 2 points. So that also helps you. That's important for later. So you have to write the formula every single time that you work a problem. You can't do it once and say, here you go. You have to write it every single time. That's required. It's worth a point on every problem. The formula is a squared plus b squared equals c squared. Here we have the legs. They make up the right angle, 28 and 29. So we're going to take those, we're going to square them, and then we're going to equal the square of c. So you write a squared plus b squared equals c squared. Then you take the two legs, you say 28 squared plus 29 squared equals c squared. Then you square 28 and 29, you get 784 plus 841, which equals 1625. And then we're going to we have to show our work. This is how you show your work. So 1, 2, 3, 4, 5. 5 points for these problems. Because 1 point there, 1 point there, 1 point there, 1 point there, and 1 point there. So you have to show your work. That's why we did the square root stuff before, so that you knew I expected that. So you take the square root of both sides, and the square root of 1625 is about 40. You don't say 40, you say 40 units because we're talking about measurements. So we know that you can take, anytime you take a square root, you can take the positive and the negative value of the number, but because we're talking about measurement and distance, there's no negative root. We don't even worry about that. We only take the positive square root. So here we go, where we're solving, whenever you use the Pythagorean theorem, the directions will say, solve the missing side of the right triangle. And when you use the Pythagorean theorem, you're solving for a right triangle. Now here we go, we have a little something different. We have this and this, but there's no labels. It doesn't say A, B, and C. So you have to be able to recognize which one is A, B, and C. Well, we're given C, we're given the hypotenuse because it's directly across. So once you realize this, you do not have to write the formula like this. But why don't we set up the problem where we're manipulating because we're given the hypotenuse. So instead of going to a squared plus b squared equals c squared, where we're going to plug in values for c, and plug in values for either A or B, because A or B are the legs, and one of them's missing, doesn't matter which one, then unless it's labeled A or B, if it's just a question mark or an X, you get to use what you want. But I'm going to manipulate this so that I don't have to have a number here and revert. You know how to solve equations like that, but I'm just going to go ahead and manipulate this and get c squared minus a squared equals b squared. C squared minus a squared equals b squared. Now I'm going to plug in c is 13 squared minus 5 squared equals b squared. Now you may say, oh, Mrs. Cohen, you said we can't equal the variable. Well, this is a little different because we have 3 variables. It's a b squared. So we're allowed to do that. And it's also, we're past that. We're setting up Pythagorean theorem. That's when you do your base equations. You don't say equal x. All right, so we have 169 minus 25 equals b squared. Now we just solve it. We get 144 equals b squared. We take the square root of both sides, and b equals 12 units. So b is 12. So that's how you would show your work when you're given the hypotenuse, and you have to find one of the missing legs. Now, I want you to try to do this problem, and I want you to refer back to your knowledge about geometry, hopefully, in triangles. An isosceles triangle has a hypotenuse of length 12 units. Use the Pythagorean theorem to find the length of each leg. Okay, stop the video, try to work that problem. When you're done, come back. You will need a calculator for the next while. So you can always use my calculators, or you can use that calculator you brought in for CTP testing. But you want to start having a calculator available because we're going to be doing a lot of geometrical stuff. So pause the video and do this problem. Welcome back. Let's see how you did. Did you catch that isosceles triangle has 2 legs that are the same measurement? That was the key because I only gave you one length. Well, let's see how you did. When you have that, you start out with a squared plus b squared equals c squared, but you realize that it's an isosceles triangle, so you can't have a and b. Yeah, you can't have a and b. You have to show me that it's the same value by replacing one of the letters. You can't say a squared plus b squared, plug in the same number, because that's not telling me that they're different. That's telling me that they're different if you go a and b. You can only have one variable representing the same value. So you want to change it to a squared plus a squared equals c squared, or b squared plus b squared equals c squared. That'll cost you a point if you don't do that on a test. It's an isosceles triangle. So here we add, we say a squared plus a squared is 2a squared equals 12 squared. 2a squared equals 144. We divide both sides by 2 before we take the square root of both sides. We take the square root of both sides, and a is about 8.49 units. Because we said that it was a and a, right? Then it's easy. Then what we can do is we can just list this once, and it's understood that that's the value for both sides of the isosceles triangle, both legs. All right. So we're going to be doing more word problems like this. So tomorrow we're going to get just comfortable with some word problems with the Pythagorean theorem. And then the next day we'll do a lot more word problems. If you need more of a reference, look in your book, and you'll be able to review some problems in there as well. 9.3 and 9.4 is the sections you should probably read over in your book. And I'll see you in class. Bye-bye. I got to turn this camera off.